My name is Nitish Thakor. I'm a professor of biomedical engineering at Johns Hopkins University, which is in Baltimore. My position is in Johns Hopkins Medical School and also in engineering. And so I affiliate myself with clinical department like neurology, neurosurgery, and engineering departments like biomedical engineering and electrical engineering. My specialty is neuroengineering and prosthetics. So brain research and engineering used to study brain. And my other research is my hands, prosthetics and robotics. How can we make prosthetic arms human-like? How do we control a prosthetic hand just like our brain controls my hands? So I study brain, I study human hand and movement, I study sense of touch and feeling. And so it's a field called neuroengineering or neuromorphic engineering. You know, brain is the seat of all we feel, all we control, right? So there are part of the brain are responsible for my movement. And a part of my brain is responsible for sense of feeling, like touch. These are different parts of the brain controlling movement and sensation. So the underlying idea is to understand how brain controls the movement and transmit those principles to a prosthetic arm, which is like a machine. But if a prosthetic arm touches something, then you have a feeling of touch, temperature, pressure, pain, and you must get that feeling back to the body, to the brain. Imagine somebody who has lost an arm. Then they need to get that, machine is here, and they need to get that feeling back to the brain so that they can feel what they are touching. So we study brain, muscles, sensation. We make it into a computer program or robotic mechanism and give it those ideas of how brain and our nervous system does all of that. I think this is what is satisfying, right? Because what we do affects amputees, people who have lost their limbs, arms, or legs. We created a spin-off company that now has given amputees prosthetic arms, like more than 2,000 in 20 countries. So these are being given to the people with lost limbs, but we are still early. So these are still robotic, not like human-like. You know, the soft hand and finger, skin-like sensation, all that is current research to make soft robotics or skin-like biomimetic, biology, human-like sensation. So current practice is combining robotics and some control, like this, what engineers do, but future will be more human-like. You know, the human-like implementation of the hands, the fingers, the touch, even integrating vision and all of that. It's not far, to be honest. It's going to be available, not too far. Professor Cheng is, of course, well known for his work in robotics and humanoid, like a whole robot-like human system. And he started a program for master's student on neural engineering. My expertise is complementary. I have led a neuroengineering program for more than 20 years at Johns Hopkins. And I work on prosthetics as like a robotics. So we're very complementary, you know, neuroengineering, robotics, and we are working like a complement to each other, you know, where his expertise in robotics, my expertise in neuro, they're coming together. Our students then collaborate on this neuromorphic, like brain-inspired sense of touch and feeling. And we do some mathematics, some engineering, some practical solutions. So that it's a collaborative project through students who collaborate and research papers and grants where we collaborate. Firstly, like it was fantastic to hear your president yesterday evening of the vision he had of taking TUM forward with huge resources, that 7 schools and then huge investment in quantum sciences and for Professor Cheng and others like cognitive sciences. And what he was saying that you have an impression that TUM is maybe technical, but they are also going into social sciences and philosophy. So that is an impressive and very rapid growth of the university, which will make it a world-class university, not just in technology, but in many disciplines. There is a lot of fantastic research and top-level people here. But I should say, I think what is in my experience, I have many decades of experience, is very rare for a university to set up this kind of funding that IAS has done, to bring top international scientists here to foster the collaboration. Because what we are doing is bring knowledge from outside and picking up something from here. So I think TUM is doing something unique in creating its international presence. Again, your president said the number of international professors and students is extraordinarily large. So it is now, I must conclude, that it's a top-class international university.